Today we are doing 6-1, Roots and Radical Expressions. And your learning goal is that you will be able to find all real roots and simplify radical expressions. So let's first discuss what a root is. So when you have a term that's raised to some power, we'll call it n. And this is equal to some number. N represents the root. So roots can be square roots, cube roots, fourth roots. It doesn't matter. So if your root is odd, then you only have one real root. And if your root is even, then you'll have two real roots, which we denote by plus or minus. And when you write it as a root, it'll look like this. And if your b, or the number underneath, is negative, and the root is even, then there'll be no real roots. Okay, so that's only if your root is even. And then n is also called the index. And the term under the square root is called the radicand. And of course, this is the radical. So we have index, radical, and radicand. Okay, so for the first example, we're going to find all the real roots. So for example 1a, we're going to do the real cube roots. And we're going to do 0.008, negative 1,000, and 1 over 27. So we're doing cube roots. So this is how it'll look. Alright, so remember if your root, your index, is odd, you're going to have one answer. So the first one would be 0.2, because 0.2 cubed is 0.008. The second one would be negative 10, because negative 10 cubed is negative 1,000. And the last one would be 1 over 3, because the cube root, or 1/3 cubed, is 1 over 27. Okay, now let's do the real fourth roots. And our numbers are going to be 1, negative 0.0001, 2, 3, 4, and we'll do 16 over 81. Alright, so now we're doing fourth roots. All right, the first one, of course, is 1, because 1 to the 4th power is 1. The second one, since our base is negative, this is no real root. And I forgot, remember, this one will have 2, plus and minus. And then this one will also have 2, plus and minus. 2 over 3. Because 2 to the 4th power is 16, and 3 to the 4th power is 81. So remember, if it's an odd root, we have, because remember it says find all the real roots. Odd roots have one answer, or one possible. Evens have 2. Okay, the second example, we're going to just find the roots. And this is different from the other one because the other problems we were just finding all real roots of what could occur. This one we're finding just the real roots. So for the first one, the cube root of negative 8 is negative 2. The square root of 0.04 is 0.2. The fourth root of negative 1 we can't do, so we just write no real root because we're only doing real numbers. It has a root, but it's not a real root. And then the last one, we have to do exponents first, so that's 4. And then the square root of 4 is 2. And if you want to try some more, here's 3 more we can try. The first one would be negative 3. 4b, you have to say no real root. And this one, remember, you got to do exponents first, and then you square root it and get 7. Okay, when you're simplifying radical expressions, one thing that you need to remember is when you're dealing with variables, because we don't know what the variable is. As long as n is odd, then you do not need absolute value signs. However, if n is even, you want to make sure that your base is non-negative. Then you must use absolute value signs. So for example, if you had the square root of x to the 8th, then because we're doing square root, Oh, excuse me. There. Because we're doing square roots, then you would need 2 divided into 8 4 times. So usually we would need absolute value bars here. But because the 4 will make it a non-negative number, then you don't need them. So this is it makes it non-negative. Now, if it was something like this, then you divide 4 into 12. Because the 3 is odd and it won't ensure that it'll always be positive, then we do need absolute value here. Because if x is negative, when we're raising to a third power, it's going to make it negative. So the evens will be non-negative, the odds will not. Alright, so we'll simplify these. The first one, square root of 81x to the 4th would be 9x squared. Now, because this is already non-negative, okay, so if it's non-negative, if it comes out to be an even exponent, you don't need absolute value bars. Okay? All right, this one. We have 12 A's and we're grouping them in threes, so that will leave us with 4. And we're okay because our root is odd. And then the second example, we have 15 B's and we're grouping them in threes, so that'll be b to the 5th. And here again, we're okay because our root was odd. So it's okay to have a negative under our odd root. Okay? And then the last example, we have an even root. So we got to be careful about our variables. So for 12 x's, group them by 4's, it would be x to the 3rd. Now, because x could be negative, then we are going to need absolute value bars around the x. With 16 y's, grouping them in 4, we get y to the 4th. And this will be non-negative, so we don't need absolute value bars around the y. So I put this note, absolute value is needed if the index is even and the root is odd. So if your index starts off even, but when you take the root, it comes out to be odd, that's when you need absolute value.